Okay, our next speaker will speak remotely. Is Boston Cartwright, and he will speak from about beyond database SQL, the driver pattern.
Thank you so much for that introduction. I'm really excited to be able to speak to you all today. As he said, my name is Boston Cartwright. I'm a software engineer at Vasion. I'm based out of Southern Utah in the United States. It's quite early for me, but it doesn't mean I'm not excited to be here to be able to speak to all of you. And I really hope you enjoyed the video, and we'll have some questions afterwards. Hi, everyone. Thank you so much for attending my talk. My name is Boston Cartwright. I'm a software engineer at Vasion. And today I really want to dive in with you guys beyond database SQL, a package we're all familiar with, but specifically the pattern that's used in it, the driver pattern. So let's get right into it. I kind of want to start today looking at some database magic, and then we'll kind of go into dependency injection, what makes it different in database SQL versus what dependency injection is. Dive deep into how database SQL works. We'll look at that pattern, look at benefits and disadvantages to it. We'll look at the driver, and then we'll also look at different applications of it and even create a driver ourselves today. So let's get right in and look at some database magic to start it off. So here I have a little project here, different numbers that we're going to use throughout the talk. But let's go into the first one to take a look inside there. And here I have a Docker Compose to spin up a quick database server and a main.go. So I'll spin that up real quick and detach from there. And then let's look at this main.go. This is a simple little script that goes and gets movies from a database, specifically where the rating is greater than 4. I've seeded this database with a bunch of fake movies, and all this does is it goes in and gets those and prints them out for us. There's some special things happening here as part of the database, and most of us are probably aware of if you've any time used the database in Go. We have our database SQL import. We import the driver, and then when we're ready to start using it, we open it, we pass in the driver string, and then we pass in the connection string that tells us where to go get it from. Finally, make that query, select all the movies where the rating is greater than 4, and then we're just going to go through and we're going to print it. So I'm going to go over here and I'm going to run this little program to show those results. And here we go. We get 171 movies where the rating is greater than 4. And so it's pretty cool that we could just go in and query this real easily with Go. But there's some kind of magic happening in here. As we saw, we just import database SQL and the driver, and it's a blank import. And that's an important part to notice here, that we're not going to actually use any variables or any globals or any methods from the driver. It's just a blank import. Everything we use is through database SQL. And then we just open, passing the string and the connection string. And so you might be wondering, how does this really pull it up? Well, we'll dive deep into that in just a few minutes. But let's take a look. If we wanted to switch the database driver we're using, we want a different database backend, we just change the string. So let's go ahead and do that. I'll just comment out these 2 lines here and uncomment these to switch my driver to SQLite 3, and I put the file that's backing this database. So we'll go in here, we save this as the opener, and then if we go and run it, we should get the same results. I've seeded them with the same things. 171 movies. Just to prove that I'm not doing any magic or any secret stuff here, we'll go and we'll run it again. I'll take that down and we'll run it again. And we get the same thing. So now we're talking to the SQLite database. And so this is kind of cool. You could just change a string and in fact use an entirely different database for us. So let's look deeper into this. But first, I want to see normal dependency injection. If you're familiar with dependency injection at all in Go, you create an interface and instructs that implement that interface using receiver methods. So in this example here, I have a cache package, very simple. You can get items on the cache and you can put items on the cache. And so for our struct implementations, we just have to implement those 2 methods and that will work for us. So if we look at an example implementation here, we just create this in-memory cache. We set the type that it's going to be. We create an initializer, and then we implement the methods. Here I'm only showing the get, but we could also implement a get and a put onto there. And so let's dive deep into that and take a look at how that really works, because if you haven't seen it before, it can be a little confusing. So here I have a main.go that's going to use our cache dependency injection interface. Here on line 15, we have our cache repository, which is an interface. If we follow that, that is the exact interface that was shown on the screen. And if we look at the in-memory cache that I was showing before, we see we have the get method and the put method. And in this case, it's very simple because we're just using a map to get input on there. I have another implementation of it that uses Redis. And so we can create the new Redis client. We have a get that puts it on there and a put. Ideally, this is not feature full. It's just a simplified version of what you could do with this interface. So if we were to take a look at how that works, I'll go to that one. I also have a Docker Compose file here that will just spin up a quick Redis server for us. We spin this up, and it'll take a second to spin up, but then we can run it. Now let's see what cache type we're using. So our current cache type is Redis. I'm just using a switch statement to switch between them. So we should be able to go in here, we put data in the cache, and then we try to get data. So we should see a result of go rocks because we just print the data at the very end. So if I run this main.go, we get the data go rocks, which is awesome. If we wanted to switch the cache type, we could just change the string, something like not Redis. And then I'll also take down my Redis server. And we'll run it again, and we should see the same exact output. It puts it on there. So this is kind of cool because we're just implementing this interface, and then we just use the interface everywhere. If we look at repo, for example, on line 24, it's still just that cache.cache interface. We don't know anything about the backend that's running there. It's just a cache. Now, for database SQL, it's a little different. When we were looking at the SQL.open function earlier, it actually returns a database struct, not an interface. And so the backends aren't implementing this interface of a SQL database. They're doing something a little different. So how does it really connect? And let's go take a look deeper into those functions there. So I'll go back to our first example here, and I'll go into the SQL.open. If I hover over it again, we can see it returns a pointer to SQL.db. Let's follow into there and look at the Go standard library of this. Here's the open function as I was just showing, and let's find this DB. If I go into here, we see it is a struct. It has a bunch of information in here. It holds some mutexes and some connection things, but it's really just a struct. But what's special here is we have the driver.connector. And this is really the main driver of this pattern is drivers implement these interfaces within the driver. So let's follow where this is. And we can see we have the driver type. This is an interface that they implement and then get injected into through a register function within the init script. So the driver is how we really use different database backends. Database SQL does this all under the hood that we wouldn't have to normally see. So this is a really good diagram of how it comes. We see we have the DB struct. And the DB struct uses the driver.driver, the interface we were just looking at, and then different database backends implement that driver. Here I have a PQ driver for Postgres, or I have a SQLite driver. There's many drivers. You can go see a list on go.dev. And they just implement this driver.driver. Now, what does this really do for us? It's a really good question, and let's dive deep into there. This pattern that's used here is called the portable type and driver pattern. This is a name coined by the Go CDK. We don't have a really great name or official name for it, but I feel like that captures it really well. The only issue is very long. So I've shortened it to call it the driver pattern. But if we use that name, the DB is the portable type, and then we have drivers that implement it. So for database SQL, why couldn't we use normal dependency injection? There's some really big points here I want to get across that make it so pretty obvious why we couldn't. So first, adding new capabilities requires all implementations to update. So if database SQL was an interface and we just had different backends implement that interface, if we needed to add any new capability to the underlying interface, all the implementations have to go and update it. And that can be really troublesome for all the maintainers of those drivers and so forth. The other thing is, and this, in my opinion, is the biggest benefit here, is we're able to encapsulate all functionality that is common to the different backends. And so all SQL databases need to do some sort of connection pooling or setting up transactions or doing different things like that. And database SQL as a struct, the DB struct, is able to do that work, and then you just call the driver to do the part that's talking to the database, and that's it. So they can have this functionality common in the struct, and the drivers don't have to implement that kind of stuff. The last thing is Go really recommends interfaces to be small. If we need a big interface for talking to a database, that's going to be very long. And so the driver allows us to make it smaller, make it more concise and more clear and simple. And that's some really awesome things. So that's where this pattern really kind of elevates and is great to use. We have the DB, it uses the driver, and then the drivers just have to implement the talking to their database backend. So let's take a look into that a little bit. And I want to really look into this query function here. So we saw the open, but if we dive into this query function, query executes a query that returns rows, right? But we just pass in what our query is. If we follow deep into it, we see it does some context working and it creates a connection. It also sets up some retries here. If it's a bad connection, it's going to retry again. That's something the driver doesn't have to worry about. We'll just do it right here. We could go a little bit deeper, creates that connection. And then what I want to find is where we get to that driver, and it's right here. So query DC executes a query in the given connection, and it gets the driver and an interface off of it, the query or context. And then it uses this driver to actually talk to the database. And we see that specifically on this line, context driver query, it goes in there, it talks to the driver, talks to the database and gets it and comes back. Then it does some more stuff like releasing the connection, setting up the rows so we can handle it, and releasing locks and all that jazz. And so this is cool because all the driver backends don't have to implement any of this work. All they have to do is implement the specific part talking to their driver, talking to their database, and the database SQL package will take care of the rest here. So that's kind of one big part of it. So benefits here, kind of opposite of the cons of why we couldn't use normal dependency injection. But first one, right, contains common functionality. That's, I think, the biggest benefit to this. The other thing is methods can be added to the type without breaking compatibility. As long as the driver supports it, we can add some new features to the type. And then the opposite would be we'd have to add methods to the interface, which we said is a breakage change. All the implementations have to go updated. The other thing is it removes the need for typecasting and conversions. So because database SQL can do all that work for us, we know the types going in and coming out, we're able to really remove all that typecasting and conversions. That's huge. So what are some other applications that we could use this pattern for? The Go CDK is a great example of this. In fact, they have many, and I do recommend going and taking a look, but they have things like the blob bucket. So we have different cloud platforms that support a blob bucket. We have the AWS blob bucket or S3 bucket, the Azure blob bucket. I'm sure GCP has something as well. The other thing is we could use it for like an event and message bus. This is actually something that we did at Vasion. We were using a homegrown event bus for many years and it was working great. But we knew that in the future, as we scaled up, we needed to get something that was a little more tried and true. And so we weren't sure what it was going to be yet. It could have been RabbitMQ, Kafka, Azure Event Bus, any of these options. And so to prepare ourselves for that, we switched our event bus usage to using the driver pattern. And we're going to look deep into that code that we set up a little later. But it worked really well. This last year, we decided we wanted to follow through with RabbitMQ. And we were able to create a driver for RabbitMQ and then just swap it out in our code, 2 lines in all of our services. It wasn't a big deal. And it made it really easy to do that switch. Some other ideas we could do are cloud secrets or even caching solutions as we looked at the normal dependency injection. I think the driver pattern would be really helpful there as well. So we've kind of talked about these things, but we haven't really looked at a driver. What does a driver really look like? And it's just an interface. So we kind of go back to normal dependency injection, but we really elevate it. And that's really what I want to drive home is the driver pattern, the portable type and driver pattern is just dependency injection with some added features on top of it that allow us to get some really nice benefits. And so I want to talk about that event bus example I was talking about earlier. So if we were to take the same diagram, we have the bus, which uses a driver.driver interface. And in our example today, we might use an in-memory driver, or we have a RabbitMQ driver. And these just implement that interface. I really like this event bus example because we're talking about drivers, and so it really becomes the bus driver, which is a funny name to call it. I love it. So we'll move on, and let's take a look at how we can implement this driver together. So if we look at the current example I have here, and we'll go to this third folder down here, I have a main.go in here. This does very similar to what we were looking at earlier. We have movies, and then we're going to, I have a long list of movies down here, movies.json. We'll go into the movies.json, and we'll put some things on there. We'll get a random element from that slice, and we'll just push on the bus. At the same time, we'll subscribe to the bus and listen to any messages that come on. It's a simple pub/sub system here. And so I've set up already the bus driver, and we're using the Rabbit driver. So let's look at what that driver looks like. If we go into the driver, we have some things in here. We have a message type, but here's the real driver. It's an interface that has a method of open connector. This open connector does exactly as it says. It will return a connector where further connections will be made. We have the connector, which has one method to connect, and that returns an active connection. When we look at the final interface here, we have the connection that can have two simple methods. It can push and it can subscribe. And that's all we really have to handle here. So let's look at the bus package that implements the actual struct that is worked off of. We have this bus struct. It holds that connector, as we were saying. It also holds a number of topics that it's going to be subscribed to, and it holds a function in order to cancel the subscription, which is just a context cancel function in this example. Now, when we look at the database SQL, you might have noticed we just pass a string. We don't have to say anything else, and then we pass the blank import. That blank import is really important to get in there, otherwise you won't be able to find the driver that you need. And if we look here, I talked about a register function as part of that. Here is the register function for this event bus. You pass in the name of the driver you're going to register and the driver. And then in here, we maintain a global map and mutex to make writing to that concurrent. We maintain that as the drivers. So all we need to do in order to use one of the drivers is we make sure we have that blank import like we have here. And then inside the blank import, and I'll pull up the Rabbit example here, we have a init function that registers it, and that's how it goes further down. It knows it's there, and it is able to use that. And so in our main, all we have to do is import this. We import the bus struct, that package, and we're ready to go. And so if we look at this Rabbit driver, I kind of showed this already, but we have the open connector in here. We create a new configuration, we create the connector, and we do a test connection to ensure it works. Then in our connector, we actually create that AMQP connection, we create the channel, and we return that Rabbit driver there. And then in our connection, we have our push, which does some cool stuff. It makes sure we can acknowledge messages or unacknowledge if we need to. And then we have our subscribe. We implement those two methods that we looked earlier in the driver, and this one will also consume and do any of that. And so that's as easy as it is to get a driver up and going. So in here, I also have a Docker Compose that will spin up a short RabbitMQ server. So if we spin it up, here we are. And then we can run our main.go. So just to double check, our driver is Rabbit. We're gonna open it. It's very similar to the SQL.open. We have the EB, which is our bus.bus. We're gonna subscribe and we're gonna put messages on there. So if we run this, we should see that some movies are gonna come and go. Maybe we could use this for some new movies releases or anything fancy like that. We can see these ratings, and we can see their revenue and their genre and their title. So they're all coming, and this will go forever until we stop it. So let's go ahead and stop that. We'll take down our Rabbit, and I want to take some time together to go in here and let's implement this in-memory driver. Now we could think of some examples maybe for unit testing or API testing or any sort of testing. You might want to use an in-memory driver rather than an actual Rabbit driver started up, or some other things that you could see to use this actual driver. So let's write this together and see how easy it is to create a driver. The first thing we'll do is we'll go into this event folder. Just see the tree here. We have the driver, the bus, and that's the Rabbit driver. So let's create a new one that is the memory driver. We'll go into there and we'll go into memory and we'll create a new file in here and we'll call it driver.go. So if we go to driver.go now in the memory package, and then there's nothing in here. So first we'll have to declare the package, as we all know. And then we'll declare our bus driver type. So this is the actual driver that we'll be using in there. And we know this needs to implement one method, that is the open connector. So let's make sure we can get that signature for the open connector. And if we find driver, here we are, open connector, returns a connector and an error. So what we'll do here is we'll go in here. It doesn't take anything in, but it returns a driver.connector and an error. Now I think it's gonna cause the wrong import, so I'll fix this real quick. All right, we fixed this import here. And then we'll need to create a connector as part of this. We haven't created that struct yet, but we'll go and do that. We'll test our connection. And what we could do here is just discard the result, but see if we get an error. And we know this is going to implement connect because it's going to implement that driver.connector interface. If the error is not nil, then we can return the error. And then we'll return the connection. Now the final thing we need to do here, and we have to make sure we remember this, is we have to register our driver. So we'll register it with the bus, and this will be our memory driver, and it'll be this struct that we created earlier. Capiche? That's the driver one. So now we can go on to our next file, and that is the connector. So if we are to open up the connector, same thing, we need the package memory. And I'm actually going to go and copy these imports because we're going to need it. And then for that, we need to create our connector struct. Typically, this would maintain some properties, some like connection strings or configuration or an active connection. But for our in-memory, it's not going to maintain anything for this simple example. So next we'll set up the connector and just remember what functions we need to implement in here. We have just the connect function on this interface we need to implement. So we'll just take that, we'll go back, and we just need to return that driver.activeConnection. And in here, we're not going to do anything special. We're just going to return that active connection. This con hasn't been created yet, but it will be created very soon. So we implement this connector, and that's all we need to do in here. It sets up that connection. In this case, we don't actually need to do any special connections, so we're just going to return the connection and return that. Lastly, we need to create that active connection. So we'll create a connection.go. Now, if we take a look here, we have the connection, the connector, and the driver. So let's go into that connection file, same package. We'll import that same thing, the driver, and then let's create this connection. Now for our in-memory store, we're just going to use a simple sync.map. So let's set that up as a global variable just to make it easier for us. So we have a sync.map. And what this really is a map. It's a topic.name, and then it's a channel that we can return a driver.message. So we'll keep a map of channels based on their topic name. And then if you want to listen to that, you would just listen to the channel, any messages that come on there. If you want to push to that, you just push on that channel. So we'll have this global store for the in-memory bus, which is awesome. We'll create that connection struct as we were talking about earlier. And then we need to implement two methods here, and let's double check what they are. If we find con down here, we have a lot of them. And here we are. So we have this interface. We need to implement push and subscribe. So we'll go ahead and implement push first. This is going to be off the con. We'll implement push. And we'll make this a driver. This is a driver.message, and we return an error. So in here, what we need to do is we need to go and get the channel for this topic off of the map, and then we have to put a message on it, just normal put things on a channel. So first, let's get channel out of sync.map store. So what we could do a value. We can load or store. And our key will be the topic name, and if we don't have it, we'll make a channel of the driver.message. So that way, if we don't have it, we can just create it and it will get put in the store. So whoever calls it first will get it there. Finally, because we're using a sync.map, we need to do a typecast to make sure it's a chan of a driver.message. Now, if it's not there, if it's not that type, then we really got a big error there that hopefully shouldn't happen because we control what's going on in that store. But if for some reason it happened, we could say map value for key, the topic or name was not of right or of correct type. And we'll just put in the topic.name here. And then finally, we'll put the message on there. Put message on channel. And this is the message. And then we'll return no. We were successful. So we went, we got it. We did a typecast just because we're using a global store. And then we'll return, we'll put the message on the channel. And then anybody subscribing to that channel should be able to get it with no issue. So let's write that subscription function here. So same thing, it's called subscribe. Let's go take a look at the driver just to double check. Here is the implementation we need to do. Subscribe, you pass in a context and your topics, and you get an error. So let's take that and we'll just put it right here. We'll make this a driver, the correct type. And in here, we need to do a very similar thing, but for all the topics, and we don't care about our index here, but we'll say this is a topic. We need to do the same thing as above first. So we'll copy that down. We could abstract that in a future iteration and refactor. We have the channel, and then what we need to do is listen to this channel. So we'll create a go-func to do that. We'll take in the driver.topic. We'll take the channel, and I'll call it B here. There's a channel of driver.message. And then to pass into it, we pass in the topic, we pass in the channel. Now in here, we just need to range on that channel. So what I'll do here is we'll do for message on range of the channel. All right, so inside this loop, we will just call our consumer. Now, our topic has a consumer function that takes in the driver.message. We'll just call it. This returns an error. So what we'll do is we'll double check that error. So error equals, then at the end of this, if the error is not nil, then we can log in this example. Error consuming on topic Q, and we'll have the error. And then we'll have t.name, so we can write the Q, and then we'll also type the error. And that should wrap it all. Finally, we have to return nothing. So we start all these functions. We also need to make sure we wait on it. We hold on subscribing until they want to be done. So we'll wait for the context to be done. And if there's an error for some reason, we'll return context that error. That way they can get the result from that. In here, we probably also in the future iterations should listen to that context, and that way we end the loop if it is ended. If the channels don't get closed, but the context is closed, we can make sure all those things, but that can be done in a future iteration. But Now we've created that driver. Now, just a quick reminder of this, right? We went and just created this memory.driver and this rabbit.driver. And I know we're all excited to see it run. So let's go in and let's run that. We'll go into our main.go. We'll change our driver to memory. Now we need to make sure that we import that. I have that import already here ready for us. I'll uncomment it. We have the blank import of it. And then we should see, it should give us the exact same output. Well, it might be a different movies that come in order because we're using random, but it should be able to act the same way. So let's do that. We'll double check to make sure our rabbit server isn't up. We'll do .ps, looks like we're all good. So we'll do go run main.go. And we're working, we're using an in-memory bus that we were able to write together here in 10-ish minutes and be able to create that driver. It's super useful for testing. This really shows the power of the pattern that we're talking about today. And to do a final recap for us, first thing we have is database SQL is complex. It's evolved over a long time, but the pattern that it's really ended up at is really powerful, something we can use in many different places and can allow us to really gain some flexibility in our programs. Cloud services are really well suited for applications of this pattern, including the database. I'm sure there's lots of other great applications, but when I first think of it, cloud services come to mind. And then finally, creating a driver implementation is straightforward. We were able to do it today in 10 minutes for a test implementation. And so anybody can use this pattern and be really powerful with it. So thank you for coming to my talk. Hope you gained some value diving into this pattern. I hope you can use it in your daily work. Thank you.
Awesome. Thanks so much for watching that with me and writing that driver with me. It was really cool to be able to use this pattern. I've been writing Go for about 3 years. And this last year, we were tasked with that challenge of, okay, we have this homegrown event bus, but we know we need to move to something more. We knew that we needed to get something that was going to be more powerful, more reliable, and be able to scale better. And we didn't know what solution we were going to use. There's lots of discovery work going on. So I was tasked with finding a way to make it easy to switch. And I looked at the normal dependency injection for that exact example of an event bus. And I felt like doing that, I was going to have to re-implement a lot and do other tedious work that kind of didn't give me the benefits that I needed. And so when I was looking at database SQL and how it worked and that special driver pattern, it really came to mind that, oh, this really works well for our solution. And as a case study, it did. We were able to, when we knew we were going to switch, I went and I switched our usage of our homegrown event bus to use a driver instead. And we were just using the event bus driver or package and then using the driver for our own event bus. Then once we settled on RabbitMQ later in that year, we went through and we created a driver for RabbitMQ. And it supplied our needs and our interface. I'm sure there's other interfaces for using RabbitMQ out there, but we created our driver to supply ours, doing things like creating that connection. And you saw a little bit of that driver as part of the presentation. And so we went in and we created that. When it was time to switch, we had Rabbit running in all of our cloud environments and we were ready to switch. We made the driver string an environment variable. And then in production and all of our environments, we were able to just switch that environment variable and watch the events flow from one service to the other. And then slowly over time, we went through and we removed the other blank imports and got rid of the homegrown event bus. But it was really easy to be able to just switch and have all the same feature set, everything there. It was really cool to see that happen and to be a part of that transition. Now, one thing I also didn't talk about a lot there is we looked at the normal dependency injection cache example. And I really like that example because we're able to, in that example, you only use it as dependency injection, but you could use that as a driver as well. And there's one point I made in there that if one of the benefits is that you could extend functionality without having to change implementations of the drivers. And I think the cache is a really good example of that. Is you could, for example, in our example, our code that we looked at today, we could have extended that using the driver pattern by having the struct, the portable type, implement a flush function. And that didn't have to necessarily be on the driver. We could have maintained a list of all of the keys that we put in there and then went and flushed those keys, and then the driver wouldn't have to update that. Granted, in the long run, it'd be more efficient if the driver implemented that and provided that for us. But it's kind of a cool idea that we could have done that without having to make drivers update their implementations. Now, if you look at database SQL and you look at all the drivers they have and all the evolutions it's had, then it really makes sense why this driver pattern really came to fruition. And what I really like looking at that standard library code for the database SQL package is you can see how it has evolved over time. They didn't start with this pattern. They started with some ideas and they built on top of each other and built on top of each other to what it is today. And I really encourage and recommend taking a look at that to really understand how that came to be. And it's really cool to learn about, to be interested in, and just to be able to see some intellection in the code that we use every day. It was really, really awesome. So I'm really excited to be able to show this pattern. I'm thinking of new use cases for it all the time. I hope some of you can find your own use cases for it, and I'm totally down to hear more about it, to hear from you and how it's working for you. But I'm really excited we're able to do that today. So thank you. I think we'll move on to some questions, right?
Hello, my question was about the implementation that you showed for the driver. Is it okay to use it, for example, when we want to do unit test as a database, or should we do something different in our implementation to use it in unit tests?
I think it totally makes sense to use it in that use. For example, especially in unit tests, it's really good because you can just swap out that driver and none of your fully backend code changes, right? You're not going to run into issues with the driver having different implementations because what the code you're really testing is that portable type. And I think that's a great example of a time that you can use it. Granted, when you get to integration tests, of course, you want to use the actual backend and the full stack that you have there. But I think that's a really great example of a time when to use an example driver. So great question.
Thank you.
Thank you, Boston.
Thank you so much. Good to be here.